So what are the environmental impacts of oil and gas production? So we need energy. We use it for transportation, to produce fertilizers for all sorts of different important parts of our economy. But along with that, we get a lot of environmental issues. So one of those, as I mentioned, is that you need to bring water into these sites whenever you drill, whenever you do fracking, whenever you have a secondary recovery process to pressurize the formation. All those things are going to take water away from some place where it might otherwise be used. I put a little diagram here just to remind you of what the well might look like. So up here near the surface, that's where we get most of our groundwater that we use for drinking water and for agriculture. Whenever you drill a hole down, you have this oil and gas and produced water coming out through here. It's under pressure. You sometimes get leaking, so you can get contamination of the surface. When the oil and gas gets transported, when the produced water gets transported, that can spill, so that causes issues. Then there are air pollution, climate change issues, and then the last couple that I highlighted there are seismicity. So you spend a lot of time doing something deep underground, there's a potential to have some sort of impacts on the stability of the land surface. So, and that is related with produced water, with this produced water management issue. But what do we do with all this water that comes up to the surface? And so, in Oklahoma over the last 10 years, we've seen a sudden surge in an area that didn't used to be seismically active. It's become very seismically active, and so these are some data from the Oklahoma Geological Survey that keeps track of this, of all the seismic events that are greater than a 2.0 magnitude. And you can see that right about the same time that the oil and gas production started going up, we started seeing more seismic activity. And this year doesn't look like it's going to be quite, or I guess 2016 was not quite as much as 2015. That also kind of coincides with a little bit less production from the oil and gas industry. So there's a question of, is this fracking causing earthquakes? I'm not a geophysicist, but as I understand it, it is not the fracking process that causes these seismic events, but it is the injection of the produced water. So the produced water is salty. What do you do with this salty water? It is not, you can't use it to grow crops, at least in the state that it's in now. So the easiest thing for the oil and gas manufacturers to do is to just simply take it and put it back underground. So this shows your oil producing layers here. You have a well, you take the oil out of the ground, you also get the produced water with that. You separate that at the surface, send the oil and gas to a refinery. Then you have this produced water. What do you do with it? So right now it gets collected, it gets taken to some other injection well and injected deep underground. And these deep injections are what is, as I understand it from the geophysicists, this is what is causing the seismic activity here in Oklahoma. And so the question is, can we do something other than inject this water? This is a major research question that we face here. So, okay, so yeah, I would emphasize this is not a new problem. So produced water has been part of oil and gas from the beginning. We've always got it, but because of these new boom in production and the associated produced water, it's become a new issue in the last 10 years. So the produced water, again, it comes up to the surface along with the oil and gas. It's initially separated there and stored in tanks. Periodically, trucks will come and haul that off at most sites, and they take it to these injection wells. The characteristics of the produced water tends to be salty, as I mentioned, but the salinity can vary quite a bit. It depends on the formation that you're looking at. So seawater is about 35,000 milligrams per liter. Produced water can be in the low thousands. It can also be as high as 400,000 milligrams per liter, which is pretty close to the solubility limit of salt. So with that sort of salinity levels, it's not a easy thing to deal with in any way other than putting it back underground. The Earth's core naturally has some radioactivity. That's one of the things that keeps it warm. And so some of that, the deeper down underground you go, the more likely you are to find some radioactive materials. Some of these formations have radioactive materials, something you have to think about once you bring it up to the surface. There are also heavy metals, hardness that's in the water that causes scale, and there's oil and grease that is mixed in with the produced water from the oil and gas. Then you get the organic contaminants that come along with those things. So anyway, because of this complicated mixture of all these different things, the easiest thing has always been injected underground. But because of this seismic activity, there's a lot of momentum now to try to find alternative approaches to manage that water.